Hi guys, welcome to another virtual lab. We are going to be working with over-the-counter medications today. I have some pain medications as well as some anti-acid medications, and what we're going to be doing is we're going to be running a series of tests on each of those and then just determining the results of each of the potential reactions, ways that they behave in different solutions, and then finally we'll use that information to see if we can figure out the identity of two unknown prescription tablets. So let's go ahead and get started. What I've got set in front of me, as you can see here on my little docu-camera, is all of my different medications already in their rows. What I'm going to do is I'm actually going to take them out and grind them in my mortar pestle, and then we're going to do just like a little bit of it into each of these containers here. So first one we're going to do is aspirin. So let me go ahead and grind that up, and then we're going to put just a little bit of that powder into each of the wells here. It says just a few granules, so that's what we're going to try and do. All right, what I'm going to do, because what I'm seeing happen is like the powder is getting stuck into the mortar and the pestle itself. What I'm going to do is I'm going to put a paper towel down for each of them so then I can just kind of shimmy them in. So give me 1 second here. All right, so I have some paper towels here. That'll help me then actually be able to make sure that not all my powder is just getting lost to the mortar or the pestle. So I got my aspirin powder in there. Let me put a little bit over here because it looks like that could use a little bit more. So just a few granules, so I think I'm doing good. Okay, now I'm gonna grind the acetaminophen. So those are all of my pain medications. Now we'll do my antacids. So first thing I'm going to do is add 15 drops of deionized water. So let me get 4 little beakers here. Okay, so I'll get some deionized water here, and I'm going to do 10 to 15 drops in each of the wells. So we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, you hear that fizz? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so these two fizzed like audibly, like I could definitely hear it. So that was an interesting reaction there. Definitely something to keep note of. So that was our deionized water reaction here. Let me use my toothpicks to mix these up and see if any of them are going to dissolve or if they're just gonna kind of stay in their chunky form. These still seem to have residual powders. Meanwhile, this Alka-Seltzer completely dissolved. Let's see, my acid control complete looks like it's also trying to dissolve completely. This one also looks a little fizzy, but it wasn't nearly as fizzy as the Alka-Seltzer. Generic still has some powder left over, and then my unknown also fizzed pretty audibly and is pretty dissolved, so that might give us a hint as to what our unknown is. So that was my appearance and solubility in H2O. Now we're gonna do the universal indicator. So I've got that here. Okay, so for my next row, what I'm gonna do is I'm gonna add 10 to 15 drops of my deionized water once again. It's doing its thing. Let me give these a good mix before I then am going to add my universal indicators. So now we're gonna do 3 to 4 drops of my universal indicator. 1, 2, wow, that was dramatic. Wow, look at those reactions. Those are some beautiful colors that we've seen here. So maybe you want to take a screenshot to be able to see these colors, and then now what we're going to do is find the pH of all of these solutions as they reacted with the universal indicator. Okay, so we're going to use our pH strips, see if we can find the pH as they react with the universal indicators. So let's look at the actual chart here. So if we look at this, you can then use this to try to determine the pH of our different substances here. So looking at our papers, I would say this looks to be about a 3, 8, maybe a 7. Looks to be like a 4, 3, almost like a 2, 2, and then over here, I think we've got like a 7, almost 9 over here. This is like a 7, 8. This is like a 9, 7. And then this is more, looks like a 7, 8. All right, so I'll hold this here in case you guys want to be able to see it a little bit longer. Now we're gonna move on to our reaction with the hydrochloric acid. This is supposed to simulate as if this was in your stomach. So let's go ahead and pretend like we are ingesting all of these chemicals now. So what we're gonna do is we're gonna do 10 drops of my hydrochloric acid in each of the wells. 10, listen to that fizzle. That's how you know it's Alka-Seltzer. Ooh, that one got a nice fizzle. That one is slightly fizzy. This one is definitely more fizzy than the other. So now we're going to give them all a stir with our toothpicks. Help that reaction occur should there be one. Man, that Alka-Seltzer really just disappears, doesn't it? This acid controller complete also looks like it's dissolving much faster than it did in the deionized water. Perfect. So now we're going to do a pH test of all of that as well. And what we want to look for while we're doing this is also for color change over time in these wells too, which is nice about having this as a recording. We can kind of rewind and go back to the before and the after. So let me get some strips for us to do a pH test with these as well here. Okay, so I'm going to put these pH test strips down here. Wow, look at that dark color. I mean, it's not a surprise because our hydrochloric acid is an acid and it's a very strong acid. Our stomach acid is extremely corrosive. So I'm not surprised that these are a nice dark red color. We'll look at our indicator strips in just a second to see then what that actually means in terms of its pH, but I can tell you right now, at least these are looking really acidic. So that being said, really curious to see how then it'll react to the acid controllers and see how good these antacids are at preventing us from being too acidic here. Wow, generic, you don't do anything, do you? That's a little shocking. Alrighty, so now let's go ahead and see what our indicator strips tell us. So as you can see, all of these are about a 1 or a 2, right? Looks like none of these have helped in terms of reducing the impact of the hydrochloric acid. It doesn't dilute it whatsoever. If we look over here, we can see this looks to be like a 6. Acid control complete. Look at that. It's going almost to a 7. Kind of like a 6 or 7. I'd say this is more like a 5. My generic didn't really do anything, right? It still looks pretty acidic. And then finally, this looks to be about a 5. So acid controllers definitely did help buffer the acid from the hydrochloric acid, make it more towards neutral, which makes sense. You're gonna take an antacid if you've got a lot of acid in your tummy. So that's cool to be able to see that those do actually work. And I mean, if you're looking for a really strong one, apparently acid controller complete's the way to go. Okay, now let's go ahead and do our last one, reaction reaction and color with our iron nitrate solution. We're gonna put that in here. Okay, we're gonna do 10 drops in each of these wells. Ooh, we got some color change happening over here. That's what we want to be attention to, the reaction and the color change. Okay, so we can see there's some stuff going on here, but let's go ahead and give it a mix. I'm going to use the other side here so that my hydrochloric acid doesn't potentially have a reaction. So we want to look for two things: the reaction in terms of like, are we seeing fizzing? Are we seeing a dissolving? Are we seeing really anything notable? And then we also want to see if we are noticing a color change, which we definitely can already see for at least the acetaminophen and the Excedrin. Pretty significant color change here. Once again, this is nice part of having a video is we can kind of compare and contrast. It's like much more goopy and congealed with the antacids than it was with the pain relievers. So that's something interesting to note. Okay, so let's go ahead and let this do its thing for a little bit, see if these reactions change at all. But right away, you can see that there's different colors abound, right? This is actually a really pretty palette. I tend to like this, that's nice. Like that strip, I would totally get that in like a jewelry, put that on a pendant. Anyways, we're gonna let this sit and then we're gonna see if in about 5 minutes how these results change. As a comparison, I'm gonna leave this here so that you guys have a reference for the pH, and then we'll come back in about 5 minutes and see our final results here. Alrighty guys, so looks like we've got a pretty good set of reactions here. Hopefully you're able to see how things have changed over time. I'm wondering if this color change is more so just because of maybe a little bit of this powder got in here. I wouldn't be surprised. But yeah, so I would like to redo that one again. But now that these have all had time to sit and react, go ahead and take note. What do you notice? How have the pHs changed? How have the colors changed in the wells? What do you see happening? Like here we have some fizzing. We've got some bubbles indicated here. It looks like I've got some fizzing and bubbles here, and even the texture. Some of them look more congealed. Some of them look more watery. So it's something to take note of as well. So anyways, I'm curious to see how you guys interpret all of these results, and I am looking forward to reading your lab report. Thank you.